Hello all, welcome to my YouTube channel. Today we shall do hypothesis testing pair t-test. Okay, let us see what is given. A set of 10 students and their score before and after a teacher takes a special session is given. Okay, and we have to test whether score of students increased after the special session. Okay, so we are doing pair t-test. Why we are doing pair t-test? See the data. The data is based on the score of 10 students, okay, and they are tested twice, before the special session and after the special session. And the see for the first student, before the special student his score is 12 and after the special session his score is 10. So for each student we have a paired data. Similarly for 9 students. Okay, so that is why this data is called paired data, and when we compare the mean, this is pair t-test is used. Okay, so we shall start with step-by-step method. First we formulate null and alternative hypothesis. Before that, let us see how we formulate the null and alternative hypothesis. Let mu1 be the mean score of students before the session and mu2 be the mean score of students after the session. Okay, we define another mu d which is equal to mu1 minus mu2, the difference of mean score of students before and after the exam. Okay, and our hypothesis will be based on this mu d. Step 1, the null and alternative hypothesis. So null hypothesis, as we know, the hypothesis of no difference. That means we say that mu d, the difference of mean, is equal to 0. That means there is no difference between two means. In other words, it is mu1 minus mu2 equal to 0. Okay, and alternative hypothesis is the research question here. What is it? We have to test whether the score of students increased after the special session. Score of student increased. That means before the session the score was less and after the session the score is more. That means mu1 minus mu2 before minus after should be less than 0. So we write it as mu d less than 0. Okay. Now our alternative hypothesis is containing this less than sign, which indicates a left directional alternative hypothesis, and the test will be left-tailed t-test. Okay. Step 2 is the calculation of test statistic. Okay. So test statistic formula for pair t-test is given by t equal to d bar divided by SD divided by square root of n. What is d bar? D bar is summation d by n. Okay. So average difference. What is d? D is the difference between the two scores, before and after. Okay. SD is the standard deviation given by the formula under square root summation d minus d bar whole thing square divided by n minus 1. Okay, so for finding out d bar and SD, that means mean and standard deviation, we have to do some calculation. I have done my calculation using Excel. You can do manually or whatever way you like. So I have written the scores, before scores and after scores. Okay, and then I find out d. What is d? Before minus after. Okay, and then I find out this sum. After I find out d, that is before minus after, 12 minus 18, negative 6, 10 minus 30, negative 3, like this, I find out the total d. That is summation d. And then also I find out another column, that is d minus d bar whole thing square. Okay, so d minus d bar whole thing square, for that we need d bar. So let's calculate d bar first. Okay, so from Excel we can see that summation D was negative 33 and N is 10, a sample of 10 students. So it is negative 3.3. So we shall use this D bar to calculate summation D minus D bar whole thing square. So now the next column, okay, so D minus D bar whole thing square. So I have done negative 6 minus negative 3.3 whole thing square, okay, which actually becomes negative 6 plus 3.3 whole thing square, so 7.29. Similarly, I calculate other rows and then find out the summation D minus D bar whole thing square, that is 58.1. Now I put this summation D minus D bar whole thing square here, 58.1 divided by n minus 1 under square root, which comes out to be 2.5408. Okay, now we put these two values to calculate test statistic T. So this is negative 3.3 divided by 2.5408 divided by square root of 10. So the value of test statistic comes out to be negative 4.107. Okay, so this is the calculated value of T. Now we go to step 3, that is decision rule. Okay, so it was given that we have to test at 1% significance level. That means alpha equal to 0.01. Okay, another thing we need is degrees of freedom, which is in short written as DF. Okay, and for pair t-test, the degrees of freedom is same as one-tail t-test. Okay, and which was n minus 1. N is the sample size, so 10 minus 1, degrees of freedom 9. And also one more thing we need to remember is that the type of test. This was left tail test, as you remember from the alternative hypothesis was left directional, so it is left tail test. So we have to find out the critical value of T, left tail critical value of T for alpha equal to 0.01 and for 9 degrees of freedom. Okay, and from T table we can find it as the value is negative 2.821. I am showing you how we get the critical value. Okay, so negative 2.821. Now our decision rule will be reject the null hypothesis if value of test statistic is less than negative 2.821, because this is the critical region. Okay, and if the test statistic value lies in the critical region, that is less than negative 2.1, then we reject the null hypothesis, and if it falls towards the right of negative 2.821, which is the acceptance region, we fail to reject the null hypothesis. Now let me show how we find out the critical value of T. Now the test is one tail, left tail test, that means it is one tail test and alpha equal to 0.01. So see here one tail and you find out probability 0.01. Okay, and also from degrees of freedom we find out the row for degrees of freedom 9. Okay, so this is the row for degrees of freedom 9 and this is the column for alpha equal to 0.01. Okay, and intersecting cell is 2.821. See, the intersecting cell for DF9 and alpha equal to 0.01 is 2.821. Okay, since it is a left tail test, that is why critical value is taken as negative 2.821. Okay, T distribution is symmetrical distribution and it is symmetrical about 0. 0 lies in the center. So whatever to the left of 0 is negative value and whatever to the right of 0 is positive value. That is why the critical value for left tail test will be negative. Now we come to step 4, that is decision. Okay, our calculated value of test statistic was negative 4.107 and critical value of t for alpha equal to 0.01 and degrees of freedom 9 is negative 2.821. Okay, and we can see that the calculated value of t is less than negative 2.821. That is, the test statistic lies in the critical region. Therefore, our decision will be reject the null hypothesis H naught. Since we have rejected the null hypothesis, that is mu d equal to 0 or otherwise mu1 minus mu2 equal to 0, that means we accept that mu1 minus mu2 less than 0. Okay, we have enough sufficient to accept that mu1 minus mu2 less than 0. That means score has increased after the session. Okay, so the conclusion is there is sufficient evidence to conclude that score of students increased after the special session. Now, so far we have done the hypothesis testing pair t-test with conventional method. That is, we have found out the test statistic and we find out the critical value and we compare the test statistic with the critical value. Okay, now we shall do with p-value approach, where what we do after we find out the test statistic, we find out the p-value and compare the p-value with the level of significance. Okay, for p-value approach, the first two steps are same, that is formulating null and alternative hypothesis and the value of test statistic, which comes out to be negative 4.107. Now we go to step 3, which is different in p-value approach. In step 3 we calculate the p-value. Okay, so how we calculate p-value? First we have to understand that this is a left tail test, so p-value will also be at the left tail. And the value of test statistic is negative 4.107. P-value will be at the left of negative 4.107. So the formula for p-value is probability that t less than negative 4.107. Okay. For t-test, the calculation of p-value is not possible manually with the help of critical value table. We shall use Excel. You can use any other software to use calculate p-value. I shall show you how to do it with Excel. Okay, in Excel, we select any of the cell, put an equal sign. Okay, then t dot distribution dist. And then see options come, t distribution two tail, t distribution right tail. Since our test is left tail test, we shall only use t distribution. Then negative 4.107. Okay, and the degrees of freedom was 9, and then this is cumulative frequency, so we put true. Okay, and the p-value comes out to be negative 0.00132. So we write down the p-value here 0.0013. Okay, so this is the p-value. Now step 4 is the decision. How we take the decision? We compare the p-value with the level of significance. Okay, our p-value was 0.0013 and level of significance is 0.01. We can see that p-value is less than alpha, therefore we reject the null hypothesis. Okay, so whether the test is left tail, right tail or two tailed, if p-value is less than alpha, we reject the null hypothesis. Okay, and if p-value is greater than alpha, we fail to reject the null hypothesis. Okay, so this is valid for left tail, right tail and two tail. Now our final step, that is conclusion. The conclusion comes out to be same as in the conventional method, that is we conclude that there is sufficient evidence to conclude that score of students increased after the special session. Hope this video is useful for you. If you liked my video, Please like and subscribe to get more such videos. Thank you for watching.